Welcome back, Geometry Scholars. Today's lesson is on medians and altitudes of triangles. The essential question is, how do triangle properties assist in solving real-world problems? And the lesson objective is that you are going to be able to describe the relationship of a triangle's median to its centroid and its altitude to its orthocenter. Let's go ahead and get started. This is a continuation of the lesson 8.1/8.2 that we did previously. A little bit more vocabulary that we will be using. But I personally feel that median and centroid, altitude and orthocenter are a little easier than the circumcenter and incenter. So first up, the median of a triangle is a segment from a vertex to the midpoint of the opposite side. So it's from a vertex to the midpoint of the opposite side. The medians of a triangle intersect at a point called the centroid, and the centroid is also known as the center of gravity. So here's an example of a median. It must start from a vertex, and it goes to the midpoint of the opposite side. By saying midpoint, that means it's cutting the opposite sides in half. Okay? So if I start from this vertex, in order to effectively or correctly draw the median, I would need to be cutting this piece in half as well. And starting from this vertex, going across, cutting that side in half. So this is approximately my centroid. Okay? Starts from a vertex though. Be mindful, it starts from a vertex. The centroid theorem states that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So for example, in this one, this example, P right here is the centroid. And if I was looking for CP, from C to P, it's 2/3 of the distance from C to Z. Okay, so that's right here. CP is 2/3 of the distance of CZ. Or if I was looking for VP, so from B to P, it's 2/3 of the distance from B to Y. And that's the green one I just drew. Or if I was looking for AP, A to P, which P is the centroid, okay, is 2/3 of the distance of A to X. So for example, if AX, this whole entire blue line, was 9, how would I find just AP? Well, it's 2/3 of it, so AP is 2/3 of 9. Okay, and then we just simply solve that equation. So 2 times 9 is 18 over 3. 18 divided by 3 is 6, so AP would be 6. And we will just plug that in. Keeping in mind that when we are looking at the 2/3, we have to start at the vertex going toward the midpoint of the other side. So you don't start at the side point, you start at the vertex point. So you start right here going over to the side. Do not start at the side. And let's practice some of these. Example 1, use the centroid theorem to find the following lengths. So if AF is 9, so I'm going to find AF, so this whole entire thing is 9, and CE is 7.2, so this whole entire thing is 7.2. Find AG and GE. So I'm going to look first at AG. So here is AF, it's my whole green line, but I only need to know AG. So AG is 2/3 of the distance of AF, because I'm starting at the midpoint. I'm starting at the vertex. Okay, so A to G, AG is 2/3 of the way of AF. So AG is 2/3 of, what's AF? 9. So AG is 18 over 3, which is 6. So AG is 6. AG is 6. Okay, I want you to try to find GE. I'll set it up, and then you're going to solve. So GE is 1/3 of the way. Okay, now notice this 2/3 rule is from when you're starting at the vertex. Now we know that CE is 7.2. And if we were finding CG, we'd stay working with the 2/3 rule. But we're not finding CG. They want us to find GE. So I'm going to cover it over in red. This part is 2/3 of the way. Okay? So that means that GE is then 1/3 of the distance. So GE is 1/3 of CE. Okay, so GE is 1/3 of 7.2. So you should be able to plug that into a calculator and find what is 1/3 of 7.2. Pause the video, find the answer. If you multiply 7.2 times 1 and then divide it by 3, GE is 2.4. So GE is 2.4. Example B. In triangle RST, U is the centroid. If UT equals 18, find UV and TV. So UT is 8, U is the centroid. Okay? They want us to find UV and TV. Now, we know that UT is, so UT or TU, since starting at the vertex, is 2/3 of the way of the whole thing. So we're going to do that one first. So UT is 2/3 of the way of the whole thing, which they're calling TV. So UT and TV is what I'm working with right now. Okay? I already know what UT is. UT is 18. So 18 is 2/3 of some long number, which we're not sure of yet. We're not sure what TV is. So I need to get TV by itself. Well, TV is being multiplied by 2/3. So to get rid of that, to get TV by itself, I need to multiply by the reciprocal. Okay, 3/2. Turn it upside down. So 2/3 times 3/2, they get rid of each other. So now I have 3/2 times 18 equals TV. 3 times 18 divided by 2 is 27. So 27 equals TV. Let's see if this makes sense. UT was 18. TV I'm now getting is 27. Those numbers make sense so far? They do. TU is shorter than TB, so far they make sense. And the other one that we have to find is UV. Well, if UT is 2/3 of the way, how much is UV? It's 1/3 of the way. So UV is 1/3 of the whole thing, of TV. So UV is 1/3 of the whole thing, which is 27. So what is 1/3 of 27, or what's 27 divided by 3? 9. So now I have that this piece right here is 9. How can I check to make sure I'm right? What should these two segments add up to? They should add up to 27. Is 9 plus 18 27? Yes. So we have solved it correctly. Okay. Example 2. In triangle ABC, the median AD is perpendicular to BC. If AD is 21 feet, describe the position of the centroid of the triangle. Okay, sorry about that phone call. So with this one, we know that AD is it's the median, and it's perpendicular to BC. So I know this whole entire thing from A to D. So starting from the vertex, okay, and it went over and it bisected this line. That's the two things. So the whole thing is 21. So where would the centroid be? Well, the centroid is somewhere in the middle, but we know it's 2/3 of the way from A to D. So the centroid, which I'm going to write as the centroid, is 2/3 of AD? Well, 2/3, what is AD? It's 21. Okay, 2/3 of 21. So 2/3 of 21, you multiply 2 times 21 and divide by 3. You get 14. So the answer was 14 feet. Okay. If 2/3 of the way is 14, what is the other third? Well, that would be 7. That's 14 plus 7, or 21. And that makes sense. 21 divided into 3 equal segments would be 7 feet each, and 2 of those would be 14. A couple different ways you can check. Moving on. So we talked about medians. Now we're on the altitudes. An altitude of a triangle is the perpendicular segment from a vertex to the line that is the opposite side. So altitudes are perpendicular segments, and again, they have to come from a vertex. They start at the vertex, they go to the opposite side. They do not cut the sides in half, okay? So we cannot say that they bisect the other side. They just go to the other side. The orthocenter is the point of concurrency of the altitudes of a triangle. So where all those altitudes meet, that's your orthocenter. So perpendicular, orthocenter. The altitude of a triangle is often also called the height. When you're in elementary school, you probably dealt with the altitude when you were looking for the height of something. Okay, so altitudes start from a vertex, go to the opposite side. They form a right angle. They do not necessarily cut the lines in half. The orthocenter is where all those altitudes meet. So from a vertex to the other side, they form right angles. And the altitude is often called the height. And the altitude can be inside the triangle, outside the triangle, or it even can be on the triangle. Okay. Example 3, we are going to identify the segments A, B in each triangle. So your options are, which we've been learning, the perpendicular bisector, the angle bisector, the median, or the altitude. These are the 4 different types of lines inside of triangles that we've talked about so far. 2 last lesson and 2 this lesson. So I want you to pause the video. You're going to use one of each, the perpendicular bisector, angle bisector, median, or altitude. I want you to try and see. You're going to use each one, so there will be no leftovers, and they all have a different answer. So pause the video, see if you can correctly place A, B, C, and D. Okay, letter A is a median. It's starting from the vertex, and it's cutting the other side in half. So it's the median. We don't know anything about the angles. We just know it cut the sides in half. Letter B is an angle bisector. It's, again, started from the vertex, and it cut the angles in half, so it's an angle bisector. We don't know anything about the sides. Letter C is the altitude. It's a perpendicular line. Okay, it's a line that was drawn perpendicular, and it starts, again, from the vertex. And that's where one of the ways you can see the difference between C and D. D is also perpendicular, but it is not starting from the vertex. It's the perpendicular bisector. It was a line that was drawn perpendicular to another side, and it cut the side in half. So it's perpendicular to the side, and it bisected the 2 sides, so it's the bisector. Okay, hope that you got some of those right. If not, erase and see if you can remember them again and try them again. Okay, now for the most work that we have to do, examples 4 and 5 require some math, and we're using some graphs. We're going to find the orthocenter of the triangle by graphing the perpendicular lines to the sides of the triangle. So we have 3 sides. We have OP, PQ, and QO. And we find the orthocenter by graphing the lines that are perpendicular to those sides. And we talked about what perpendicular lines need. Perpendicular lines need slopes that are opposite, reciprocal. Opposite, reciprocal. So when we are looking for the orthocenter, remember, according to your notes, orthocenters are when we're dealing with altitudes, and those are perpendicular lines. So start from a vertex, and you're going to draw your first one. Now, it's nice. They actually gave you one. They gave you a nice straight line. Okay? And it's perpendicular, formed a right angle. Okay, so that's our first one. Okay? Or we can also think about, I wanted a line that was perpendicular to this line. Well, this line is a flat line. So what is its slope? Slope is 0. Okay? It has a slope of 0. What's the opposite reciprocal of 0? Still 0. So if it was a horizontal line, now we've drawn our vertical line. Okay? So our next one that we need to find, we're going to start at another vertex. So you can start at either vertex, and I am going to use this vertex. You can use O, or you can use Q. So we've already drawn one from P, so O or Q. Okay, so again, altitudes are perpendicular. So the line that's perpendicular to this one that I'm drawing right now is the altitude x equals 2. Okay, so now in order to find the orthocenter, I have to find a line that's perpendicular to another line. Okay guys, sorry, somebody just came in and I'm not sure what I just said. So anyway, we're drawing altitudes. Altitudes are perpendicular. So I am going to be drawing a line that's perpendicular to PQ. And I apologize if I've repeated myself again. Somebody came in and I wasn't sure where I left off. So here's PQ. I need to draw a line that's perpendicular to that. So perpendicular lines have opposite reciprocal slopes. Okay? Opposite reciprocal slopes. So this slope is up 1 over 1, 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 up 1 over 1. Okay? So it's up 1 over 1, but it's negative. It's going to the left. So that's its slope. That's the slope of that line. Okay? But the opposite reciprocal of that is just 1. Okay? Just 1. So you're going to start from right here and go up 1 over 1. Now we're going to the right. So up 1 over to the right once, up 1 over to the right, up 1 over to the right. So if you connect these points, which hopefully you did maybe slightly better job than I did, okay? I just drew a line from this point, okay? That's the altitude. It formed right angles, okay? And now I have two lines that intersect. And I could do it again. I could find the slope of OP if I wanted to, okay? And then do the opposite reciprocal and go this way from, I think it's point Q. And I could go this way. And if I do that, it should still end up intersecting right there. But as I told you earlier in class today, you only need 2 points. Okay? So where do these two lines intersect? Well, at the 2 on the x-axis and at the 2 on the y-axis. So that's the orthocenter. Right here, where those lines meet, is the orthocenter. Okay? We will do more of this in class. It's definitely a newer concept that I'm not expecting you guys to master, but hopefully you are becoming a little familiar with it. Actually, let me show you one more way. If you don't like counting, you could have done the slope formula for this as well, which slope formula is y2 minus y1 over x2 minus x1. So this is my point 2, this is my point 1. So 0 minus 6 over 8 minus 2, negative 6 over 6, which gave you the negative 1. Okay? So I ended up right here with this negative 1, and then the opposite reciprocal was 1. So when you have a picture, you can just count the slope. But if you don't have a picture, then you will need to use the slope formula. Okay, so that was orthocenter. That's dealing with altitudes. Last problem. Find the coordinates of the centroid of the triangle shown on the coordinate plane. Now look back at your notes. Centroid is when we are cutting sides in half. When we're cutting sides in half. And it's where those sides, when we cut them in half, where they intersect. So we're going to take all of these sides and we're going to cut them in half. So we're going to cut this side in half. What formula are we going to use to find the halfway point? That would be the midpoint. Midpoint is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay, so I'm going to call, I'll do this one first. This will be my 1. This will be my 2. So, okay, my apologies, an announcement came on. So 0 plus 6 over 2, comma, and then 8 plus 4 over 2. So 6 over 2, 12 over 2, 3, 6. So 3, 6. There's my first median. So from here to here. Okay, so now I want to start drawing my median from this point. So I got to look at P and R. I will make this one 0.1, and I will keep R as 0.2. Scroll down a little bit. Give me some more room to write. Okay, so x1 is 3 plus x2 is 6 over 2. y1 is 0 plus 4 over 2. 3 plus 6 is 9 over 2. Okay, and 0 plus 4 is 4 over 2. So 4.5 comma 2. And 4.5 over 2 is right there. Oh, can't scroll back up. There we go. So here's 4.5 and 2. So draw. Okay. Should be a straighter line than that, my bad. And you can stop right there, but I'm going to just go ahead and do the third point. So I've drawn the median from this point. I've drawn the median from this point. So now I'm going to draw the median from my last point. So it's got to bisect this last side, QP. So this will be 0.1, and this will be 0.2. And I'm going to use red over on the left-hand side. So x1 is 0 plus 3 over 2, and then 8 plus 0 over 2, 3 over 2, 8 over 2, 1.5, comma, 4. So 1.5 1.54 is right here, so this needs to go right across here. So now look at where all these medians, what we just did was we found the medians, because remember, medians cut something in half. So we started from a point, okay, and the side opposite that point we found the midpoint of, and then we went from our vertex to that point, we cut it in half. So now this side equals that side, okay? And this piece equals that piece, and 1, 2, 3 equals 1, 2, 3. Okay, we found all the medians and the midpoints. So where's the centroid? Where do they all intersect? They intersect at 3 on the x-axis, 4 on the y-axis. In class, we will be focusing on these types of problems, these graphs and stuff. So you need to come to class with some of this prior knowledge. Please make sure that you have done the summary, because I will be checking for that. If no summary, no credit, and have a great day.